Hey everyone, in today's lesson we're going to be looking at drawing similar polygons. Now, this is a lesson that I would normally do on the board just to make it a little bit more visual for you and to also show you the measurements. But we're going to do it together on here because we're learning from home right now. And I'll do my best to show you the exact measurements that I'm going to be using or the process to properly do this. So yeah, we're going to be looking at drawing similar polygons, and we're going to be using scale to determine if we're making these bigger or making these smaller. So there are many examples in real life when images of figures are enlarged or reduced. Now, a couple of those are obvious ones, so model cars, toys. In this movie here, for example, they had to make it appear that the people were tiny, so they had to scale up all of the different shapes around them so that they would properly looked like they were tiny, so that they had to make an enlargement of those shapes. So for example, these packing peanuts, they had to make it look like to a certain scale that the people appeared to be tiny. Now, when we're looking at enlarging a trapezoid, so what we have here on the right, it says to enlarge the trapezoid by a scale factor of 1.5, we want to look at, well, changing this and enlarging it by 1.5. Well, if you're enlarging something, you're obviously going to be making it bigger. So when it asks will your picture get larger or smaller, enlarging something means it's going to get larger. And what will the new dimensions be for the trapezoid? Well, we want to look at what dimensions do we currently have. Across the top, we have 4. On the left, 3.5, right 3.5, bottom 6. So we're going to have to enlarge these by 1.5. So to enlarge these by a scale factor of 1.5, we're going to take our measurements. So the left-hand side was 3.5 and enlarge it by 1.5. You're multiplying it by 1.5 and you're going to get a new dimension of 5.25 centimeters. So 3.5 multiplied by 1.5, you're getting 5.25. So that'll be for the left and the right. On the top, we have a measurement of 4 centimeters and multiply it by 1.5. You get a new measurement of 6 centimeters. And for the bottom where it's 6 centimeters, we're multiplying it by 1.5, and you're going to get a new dimension of 9 centimeters. So the top is going to be 6 centimeters, the sides are going to be now 5.25 centimeters, and your bottom is going to be 9 centimeters. Next, it says to draw your new trapezoid and label the measurements of the sides. Well, over here, I'm going to do my best to draw the new dimensions for you. Now, because I'm doing this on the computer, I'm not going to be able to actually measure this out properly. So what I'm going to do is I'm just going to draw the shape for you. And I'm going to label the measurement. So our top is 6 centimeters. Our left and right are going to be 5.25 centimeters, 5.25 centimeters, and then our bottom is 9 centimeters. Now remember, I didn't draw this correctly because I am doing it on the computer, and this is why I would normally do it on the board for you. But that just will give you a rough idea of the proper way of doing this. So you would measure out each dimension and draw them properly. Now moving over to the next page, we have an artist who needs 2 similar slabs of wood for a sculpture. They must have the same shape as sketched by the artist, but 2 different sizes. So what we're going to look at here is changing these measurements so that they match up with the measurements that are going to correspond with those sides. Now, they give us one measurement here, the 6 inches, and it matches up with this one here. So what we want to do is figure out first, what is our scale factor going to be? Now, to calculate scale factor, we're doing scale factor equals scale over the original. In this case, our scale is going to be the one on the right, and our original is going to be the one on the left. So we're going to have 6 over 4 because these are the two sides that correspond with each other. So our scale factor is going to be 1.5. So 6 divided by 4 is going to give you 1.5. Now that we know the scale factor, we're going to be able to find out the missing sides of A, B, and C. And we choose the corresponding side with them. So when we're doing A, we're going to have it match up with 6 centimeters, and we know our scale factor is 1.5. So to find A, what we have is 6 inches multiplied by our scale factor of 1.5. So the new measurement for A is going to be 9 inches. For B, we have a measurement of 8 inches multiplied by a scale factor of 1.5 gives us a new measurement of 12 inches. I'm just going to get rid of that dot. 12 inches. And for C, we have 10 inches, and our scale factor is 1.5. So we have a new measurement of 15 inches. So now we've been able to take our original shape and scale it up by a scale factor of 1.5 to the new shape that'll have the same angles in all the different locations, but it will be enlarged by 1.5. Now, next we're going to look at reducing figures using a ratio method. This is especially one I would do on the board with you, but because we're at home, I'm going to do my best to demonstrate exactly what this is going to look like. Now, don't pay attention to this 13 here. That 13 is just the page number. So we're just looking at the shape itself. The first thing it asks us to do is to choose a focal point. Now, we're looking at reducing the size of this figure, and what our focal point is going to be is something that is outside of the shape. So if I choose a focal point right here, this is where I want all my lines to end up. Now we want to draw the lines connecting that point to each vertex. So the vertex are going to be where the two lines meet on the shape. So for this shape, we have 5 different vertexes. So what I would do here is draw my line from here and right to this part here. Once I've drawn all my lines, this is what it should end up looking like. Now, the third part says to use a scale factor. So use half. So to do this, find the midpoint on each line segment and connect the 5 points to create your new shape. So we're going to use half of our line, so halfway to our midpoint, to find out what our new shape is going to look like. So really, what we'd be doing if we were using the top as an example is we'd be measuring from here all the way to this line here, and we would be finding out exactly where the halfway point is, and then we'd be making a little bit of a mark. So I'm not going to be able to do this perfectly on here, but I can give you a good example of what this is going to look like. So if this was my halfway point, I'm going to make a dot on here. The next part, I'd go to my next line and I'd find where my halfway point is, and then I would make my other dot on my line. Then I would move over to my next line and I'd find my halfway point and I'd make my next dot. Then I do this for the remaining 2 dots. So I'm going to have my halfway point, and then I'll have my last halfway point. And what it should start making is your shape, and then you're going to connect your dots. So you're going to connect your lines, and you're going to get a scale factor, which is going to be half of it. So your shape is now going to be half of what your original was. Now, I did this without properly measuring, just because it is hard to properly measure them on the computer here. But when you were doing this, you'd measure your line, find the halfway point, and then make a dot, and then it should make a perfect replication of your shape, but it's going to reduce the size of it. On the next page, we're going to be looking at enlarging it. So it's enlarging a figure using the parallel method. So first it says choose a point that is inside the shape. It does not need to be in the center. So I'm going to choose a point that's right about here. So close to the center, not perfect though. Then it says draw rays connecting that point to each vertex and extend the line. So what I want to do is I want to go from this point right in the middle that I just made and go through my vertex and then out and extend that line. Now I'm going to pause it and clean this up a little bit, but just that's so you just have an example. This is what it should look like after you've connected from that dot going through the vertex and then drawing the line out extending from the shape. Now, for the third part, it says choose a scale factor and use 2. So measure the distance from the center to the vertex. So what that means is you're measuring from here right to your center. So from that distance there to there, or you can do from here and then go out to this vertex. You're going to need all 4 measurements. And what you're going to do after that is double the length and measure that from the center point. So whatever this measurement is, you're going to times that by 2, and that's going to give you your new measurement, and then you would make a dot that would correspond with that on the same line. So we're going to be doubling all of the measurements, and I'm just doing an approximation right now, but you would be finding the exact same measurement and doing this on your lines. And what you should end up with is going to be a shape, and let's see if it works out, a shape that looks just like your original, but it is double the size of what your original shape will be. Now my line didn't fall perfectly on that vertex just because it created the shape for me, but it is an approximation just because I'm doing this on the computer and not doing it on the board with you. Now, hopefully this gives you a good idea of the exact way to do it, and make sure when you're going through and working in your work booklet that you are doing the proper steps when you're creating these lines so that you get the proper replication of this shape for you. Other than that, that's going to be the lesson for today, and if you have any questions, please send me a message in Teams so that I can help you out.